Right. Welcome once again to Mathematics Media. We are still on theory of logarithm on Mathematics Media, and so far we have looked at the meaning of logarithm. We have also looked at the laws of logarithm, and we are now on simplification of terms and expressions involving what? Logarithm. Please do well to subscribe to our YouTube channel, and also encourage your friends to do so, and also like our Facebook page. In the last video, we looked at the different cases in simplification of terms and expressions involving logarithm, and we said we have the first case, which is the case when we have just one log operator. We talked about the second case when we have many log operators, and then we talked about the last case, which is division of what? Of logarithm. So the first case that we're going to solve problems on is the case when we have just one log what? Operator. So we're going to begin this journey. A case of only one log operator, you look at this, these are examples of such cases. And of such case, that's the case of one log operator. Look at this. Just one log, just one log, just one log. And how do we go about it? How do we go about it? We say that there are two methods. There are two methods. There are two methods used in the simplification of terms or expressions with one log operator. These methods are indicial method and the ancestors method. So when we want to simplify a term or an expression that contains just one log operator, we say there are two methods that can be used. One of them is the indicial method, and the other one is the what? Ancestors method. And one thing is also important. Let's just make that statement. No matter the method used, the result or the answer will be the same. So quickly, let's begin with the first method, indicial method. The first method, indicial method. The name explains it. The name, indicial method, that means the principle of indices is necessary. Also, we need the principle of indices in ancestors method also. So let's look at this method. What are the steps involved in indicial method? We say in indicial method, we take the following steps. We take the following steps. Step number one, I take note of the term or expression and identify the base and the number. And identify the base and the number. That's the first step. Then the next one, equate the term or expression to a letter. Equate it to a letter. The third step, after listing this term, we'll now use an example. As we are solving a problem, we'll be following these steps. Okay? Take the base to the side of the letter and let the letter off and make the letter the power of the base, then remove the log operator. Express both sides in index form using the same base. Since the bases are now equal, we now say equate the powers and solve for the letter, which will give us the answer to the logarithm. So 5 steps that we are going to take. Then we just take note of 2 things now. Just one. I will just write it only one. Supposed to be 2 things, but I will combine them now. So we say decimal fractions should be expressed as vulgar fractions, while mixed numbers are expressed as improper fractions. Okay, quickly, let's look at some questions now. We are still on simplification of terms and expressions involving logarithm. So let's continue. Let's look at these word examples. Let's look at this now. Simplify the following. Simplify the following. Okay. Right. Number 1. Let's say I have log 32 in base 2. Okay, we want to simplify this. We are going to follow these steps. This is a case of one log operator. So how do we do that? We say one of the methods is the indicial method. So let's quickly follow this step. So if we want to simplify this using indicial method, that's my solution. Let me solve this now. We say take note of the term or expression and identify the base and the number. The base here is 2, the number is what? Is 32. We have identified that. They say equate the term or expression to a letter. Okay? Let's follow the instruction. Log 32 base 2. They say equate it to any letter. We have been in love with S. So let's say love S now. Letter S. Okay. They say again, take the base to the side of the letter and make the letter the power of the word base. Then remove the log operator. 2 things or 3 things that we are going to do here. Take the base to the side of the letter. The base is 2. Take it to the side of the letter. When you take the base to the side of the letter, don't stop. Make that letter the power of the word base. So if I take 2 to this side of the letter S, I will make this X the power of word 2. It has not finished. They say also remove the word, the log operator. So I've removed this man to this side. If I remove the log operator, the only man remaining is what? 32. Okay? That's beautiful. we are through with the third step. Then the fourth one, express both sides in index form using the same word, base. This is already in index form, in base 2. Then we can also express 32 to be in base 2, in index form. So 32 is something as 2 raised to the power 5, which is equals to this now. Remember, if I have 32, 2 divided this is 16, 2 divided this is 8, 2 divided this is 4, 2 divided this is 2, 2 divided this is what? 1. So 1, 2, 3, 4, 5. That means it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's why it's 2 raised to the power 5. So, having done that, they say it again, we have done that. Having done that, this final step, which is the fifth step, equate the powers and solve for the letter, which will give us the word answer to the word logarithm. So let's equate the powers. The power here is 5, equate it to the power here, x. So it means that x is equal to what? 5. Now remember that log 32 in base 2 is x. So it means that log 32 in base 2 will now give me what? 5, since x is equal to 5. Since x is equal to 5. Okay, we take another example. This time around, we just take it slightly easy. Let's go again. We have log, let's say I have log 27 base 3. I want to solve this. Can you follow me now? Let's go. Take note of the number and the base. We have done that, we know them. Then the next step, they say equate the term, equate it to any letter. So we have used our first law, which is x. We know we love x so much. Now let's ask y. Let's equate to what? Y. And now the next step, take the base, take this base to the side of the letter. If I take this base here, say make the letter the power of the base. So, and when you have done that, remove the log. So I've removed the log operator, remove 3. The only man remaining here is what? 27. They say now express both sides in index form. If I want to write this in index form, I'm going to use 3, and that will give me 3 raised to the power 3. When you divide 27 by 3, you have 9. Divide again 3, divide again 1. 1, 2, 3. So I have 3 raised to the power 3 plus 3 raised to the power 1. Then they say equate the word. Equate the powers and solve for the word later. Look at the power here 3 and look at the power here y. So y is equal to what? 3. It means that log 27 base 3 will give me what? 3. Since y is equal to y now, log 27 base 3 is equal to y. And we have found y to be 3. That means the whole of this is equal to 3. Okay, we still need to take 1 or 2 more questions before we end this episode. Remember, we will be back to look at the ancestors method, and after that we are going to solve a variety of questions as far as this particular aspect of simplification of a logarithm is concerned. That's the case 1. Okay, let's quickly look at another example now. Let's look at another example quickly. Example number 3. If I have log 125 in base 25. Okay? Log 125 in base 25. Remember our step. I decided to leave this. I don't want to clean it so that we'll just be making reference to it. Remember our step. Take note of the term or expression and identify the base and the word number. We have taken note of this. The number is 125. The base is what? 25. So we have log 125. Log 125 in base 25. They say equate the term to any letter. We have used x, we have used y. Let me still choose another letter. You can choose your own. Let me use n. Let me use n. Now, they say take the base to the side of the letter. So I take 25 here. I will not stop. Make that the letter now the power of the word base. And then remove the log. So this is gone, this is gone. I'm left with 1, 2, 5. Express both sides in index form using the same word base. I can express 125 in index form using 5. I can express 25 in index form using 5. So I will have 5 raised to the power 3 we know how we come about this. 5 times 5 times 5. When you divide continuously by 5. And 25 is 5 raised to power 2. Remember, we have n here already. We have n here. So 5 raised to power 2n now. Now they said equate the powers. Why are we equating the powers? The bases are now the same. So we equate the powers since the bases are the same. So we have 3 is equal to 2n. Okay, for us to solve this, we say 3. Divide both sides. Divide both sides. Both sides by 2, because 2 is the coefficient of the unknown. By 2, let's separate them. 2 is the coefficient of the unknown. Divide both sides by 2, so I have 3 over 2 plus 2n over 2. When 2 divide this, we are left with 3 over 2 equals what? n. So n is 3 over 2. So if log 125 in base 25 is what? N. It means that log 125 in base 25 will give me n. And what is n? 3 over 2. This an improper fraction. You can still write it as 1 whole number 1 all upon 2. Beautiful. 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 We'll solve 2 more problems on this. We have a reason. We want to solve a problem that will involve a decimal fraction, and also a problem that will involve a sort, a square root sign, so that we must have touched different aspects, so that no matter the kind of question you will meet, you'll be able to handle it. So quickly, let's look at a case where we have a decimal fraction. Question number 4 now. Question number 4. When we have a decimal fraction. I believe you are taking note of all this. So question 4 now. If we have simplify logarithm of 0.125 in base 4, something like this. We have a decimal. Now we said here, note, decimal fractions should be expressed as vulgar fractions. Vulgar fractions are those fractions we write in numerator denominator form. Like when you have 3 over 2, 5 over 8, 1 over 2. These are vulgar fractions. These ones are decimal fractions. So the vulgar fractions are fractions that are written in numerator denominator form. And we say when we have decimal fractions in theory of logarithm, we need to express the decimal fraction as what? Vulgar fraction. Very important. So we have this. So we have taken note of this and this. But there is a matter here, and that's why this point was mentioned when we were listing the steps. So that when you meet this, you will not say, what am I going to do? We know what to do now. We have to change this to vulgar fraction. So we have this. Log 0.125 base 4. Let's equate this to a letter. That's what our step says. So we have, let's still use our x now. So we need to change this to what? Vulgar fraction. And when we do that, we have log 1 over 8. Before you shout, I'm going to explain 1 over 8. Let me clean this part and then use here to explain this quickly. Let me clean that and use it to explain this. 0.125 is something as 125 over 1000, because each decimal place stands for a 10. So this first decimal 10, this second decimal another 10, this third decimal another 10. 10 times 10 times 10 is 1000. So by the time we now divide by 1000, we must have removed the decimal. So if you now break this down, you did fraction, reducing fraction to lowest term. By the time you continue to divide, you are going to arrive at 1 over 8. That's why we have 1 over 8. Okay? So we continue. So we now say it again, take the base to this side and let the letter become its what? Power. So, and remove the log. So if I take this base now to this side, it's 4. Make the letter the what? The power. Now what I will have remaining here is 1 over 8, because I will remove the log operator. Okay. Now I have 1 over 8. Let me express both sides in the same base in index form. So 8 is 2 raised to power 3 4 is 2 raised to power 2x. Still, they are not yet in the same base. Do you know why? It's 1 over, but this is just 2. So I need the knowledge of indices here. Let's go to the fourth law of indices. You see why I say that indices is a prerequisite if you must do theory of logarithm. A raised to power minus s is 1 over a raised to power s. So a negative index is something as reciprocal. That means if I have this, I can take it like to this, as this one can also go to this. Like something like this is written like this, and when it's like this, we can write it like this. So now it is like this. We don't need it in this form, so let's put it in this form so that we can form the same base with what we have on the right hand side. So we need to apply the fourth law of indices on the negative index. If I have 2 raised to power minus 4, something as 1 over 2 raised to power 4. That means if I decide to take it back here, 1 over 2 raised to power 4 will become 2 raised to power minus 4. So here, 1 over 2 raised to power 3 will become 2 raised to power minus 3 equals 2 raised to power 2x. Now the bases are now the same, so we need to continue the problem from this side. Okay, let's look at it from here now. From here now, we equate the bases. So we have now, sorry, we equate the powers now. We have minus 3 is equal to 2x. That's what the fifth step says. So to find x, divide both sides by who? By 2. That will give you minus 3 over 2 plus 2x over 2. When this divide, we are left with minus 3 over 2 equals x. So remember, we are looking for x, and x is equal to this. Therefore, log 0.125 in base 4 will give me minus 3 all upon what? 2. Minus 3 over 2. Beautiful. Very beautiful. All right. We can still express it in decimal, so in mixed number as minus 1 whole number 1 all upon 2. Can still leave it in that form. Okay. Now we still need to solve one more problem. We have solved 4 questions, so we need to solve one more, and that one will be a problem that involves square root sign. You can pause the video from time to time until you have grabbed what you are looking for. So let's look at the 5th question now. The 5th question. Let's look at the 5th question. We have log square root of 9, log square root of 27 in base 9. Log square root of 27 in base 9. How do we go about this? Log square root of 27 in base 9. We take note of this. That's what we have said. Take note of that. Identify the number and the base. Identify them. Then follow this. Equate the term or the expression to a letter. Let me use letter y. Let me use y. Take notes. Okay, take the base to the side of the letter. Take this base to this side. I've taken this. What will you do when you take it to that side? We say make y the power of that base. So this letter will now become the power of the base. And then remove the log operator. You know I've removed this. The only man remaining here is the beautiful square root of what? 27. Oh, square root sign. From the principle of indices, the square root of a number is that number raised to power half. You can write it down. Square root of a number is the number raised to power half. We say square root of a number is the number raised to power of 1 over 2, power of half. For example, now if I have square root of 8, it is 8 raised to power 1 over 2. Now square root of 10, it is 10 raised to power 1 over 2, and so on and so forth. So take note of this. Just put it down quickly. Do not allow it to distract you from what we are doing. Let's put it down quickly. Okay, we are back on this. So we can write this in index form. Part 1, we don't need this. This man is disturbing us. You know, look at the steps. This is not in that step. we have a stumbling block. So with this knowledge now, we can clear the stumbling block. The same way the knowledge of decimals enabled us to clear the stumbling block we had when we had a decimal fraction. So we have this now. So since the square root of a number is that number raised to power half, we can have this as 27 raised to power 1 over 2 equals 9 raised to power y. We express two of them in the same in index form using the same base, and the base that we can use is 3. The number that we can use, the common base, can be what? 3 is 3. So 27 is 3 raised to power 3. But remember, we still have half here. Good. We have half. 27 is 3 raised to power 3. Now 9 is 3 raised to power 2, and we have y here. Now when we have two powers on a number, they multiply. We call it power of power in indices. So when this power multiply this, we are going to have 3 raised to power 3 over 2. 3 raised to power 3 over 2 is equal to 3 raised to power 2y. Oh, beautiful. I think I need to clean this to help me more. So I know you have taken note of this. You can always pause this video. The same way when you are watching a movie and you did not understand what happened at a particular point, you rewind and rewind. Some people, when you are listening to music, you keep on rewinding it until you have mastered it. It has entered every part of your system. That's the same thing you're supposed to be doing in mathematics. When you see maybe something that we just did and you did not really understand, go through it over and over again, and it now becomes a part of you. Okay, so since the bases are now the same, they say equate the powers. Remember, we are following this step. So we have 3 over 2, which is this power, is equal to 2y. Oh, beautiful. We have a fraction and we have another number. How do we clear fractions? They say we cross multiply. Let's use that. Or we multiply both sides by 2 to clear that. So cross multiply or multiply both sides by 2. 2 is the only denominator here. So 2 over 2, this is 2y over 1. This is just 2. The LCM of 2 and 1, because this over 1 is 2. So we usually multiply using the LCM. So if we do that, we are going to have 2 times 3 over 2 is equal to 2 times 2y. 2 we divide, we are left with 3. 2 times this will give us 4y. So we say divide both sides. You know, indices have ended, logarithm have ended. This is just ordinary equation or algebraic equation. That's what it is now. Both sides by 4 now. So we have 3 over 4 is equal to 4y over 4. When we do that, 3 over 4 will be equal to y. So if the whole of this is y, it means that the whole of this log square root of 27 in base 9 will give me 3 all upon what? All upon 4. 3 all upon 4. Oh, beautiful and very beautiful. Go through this, following these steps, and you will become a guru in all this. All right, I believe that you are enjoying the meal, and each time we feed you, we are giving you power to trample upon mathematical principalities, and no mathematics shall by any means harm you. Oh yes, that's why we are feeding you with mathematics meal. The moment each time you feed on mathematics meal and you go out there, you meet any mathematical principality and power, you already have the energy to deal with those principalities and those powers. Okay, we are going to take a break, and this is where we are ending this episode. The next episode, we are going to look at the second method, which is ancestors method. Remember, we say that no matter the method you apply, you are going to arrive at the same answer. But we need to teach the two methods so that anyone that is convenient for you, for any problem that you come across, then you apply that particular method. Keep watching Mathematics Me. Keep spreading the good news about Mathematics Me, and keep enjoying Mathematics Me. Remember, if you want to stay away from mathematical foolishness and mathematical stupidity, you need to take a meal from mathematics mail, at least one a day. Thank you, and God bless you.